Welcome to the class on digital image processing. Myself, Dr. K. Punnamchandar, Assistant Professor, Department of ECE, Kakatiya University. And I will be the course instructor for the subject digital image processing in this semester. I have already shared with you the intro video of this particular subject. Let us start. What is a digital image? A digital image is defined as a two-dimensional function f of x comma y, where x and y are spatial plane coordinates, and the amplitude of f at any pair of coordinates x comma y is called the intensity or gray level of the image at that point. When the coordinates x comma y and the amplitude f are all finite discrete quantities, we call the image a digital image. The field of digital image processing refers to processing digital images by means of digital computers. Now, if you have a look at the digital image, how it looks like in digital format, then here this particular here we have an image of size 10 by 10 where 10 rows and 10 columns are there, and then we have values at particular cell. So here the coordinates are discrete as well as the amplitude value. Say for example at 1 comma 1, if the value is say discrete value 10, then we say that this particular image as a digital image. That is, here we have to the point is to be observed here is that the image is represented as a matrix comprising of a finite number of rows, a finite number of columns, and the value at a particular column is also a discrete number. That is, a digital image is nothing but a matrix of finite rows and columns with the value at a particular cell is discrete quantity. Then that particular representation is called as a digital image. So where we can find the images? So here in this slide you can see that the images, the electromagnetic spectrum is being shown, and it extends from gamma rays to radio waves, and on the top the energy of the photon is shown. Right now here in this one, if we observe, as humans, when we pursue the photos taken by our digital cameras, they fall in this particular small electromagnetic spectrum called as visible band. Right now, and the energy here, the energy of the photon is 10 to the power of 0, that is 1. Now if the energy of the photon is 10 to the power of 6, that is at one end of the electromagnetic spectrum we have gamma rays with energy 10 to the power of 6, we have X-rays with energy in the range of 10 to the power of 3 to 10 to the power of 4, next ultraviolet light, next invisible, infrared, microwaves, and radio waves. Each and every spectrum we can get the images. Next we will see what are all the different applications of this particular electromagnetic spectrum in getting the images. Now if you look at in this slide, there is gamma rays are shown, and these gamma rays are used for medical images as well as astronomical images. That is, we can observe the far away places in the space. On the other hand, we can use the gamma rays to get the medical images, and in this particular medical image, if you see, there are the person bones are clearly visualized. Next we go for next application. It is X-ray imaging, and X-rays are also used for medical as well as quality control of the in the industries. For example, here the example taken is printed circuit board. That is, whether the parts are placed accurately or not. Coming to the ultraviolet ray imaging, They are also used to view the uh, in the application of microscopy. That is, you can visualize the details at a very microscopic level. Next one is visible. This is where humans can visualize. Infrared, and this one is used for the urban planning. Microwaves. Microwaves, they are used in an adverse weather conditions and irrespective of time, that is day or night. They can be used to get the images. Here one image is shown of spaceborne radar. Next, radio waves, energy in the range of 10 to the power of negative values. They are also used to perform, they are used in the medical applications. Now, what are the basic elements that are used to develop a digital imaging system are shown on this slide. So here we have, first one is the problem domain here. That is, whether you are aiming at astronomy or whether you are aiming at medical or you are aiming at a microscopic level, that one will decide this problem domain. Based on that one, that problem domain, we will get the sensors. Now, these sensors are, because these sensors will be able to sense in that particular electromagnetic spectrum where the problem domain falls. After the sensors acquires the information, they will be processed using specialized image processing hardware, where the images are reconstructed for visualization. Right now, after getting this output from this particular specialized image processing hardware, the data will be sent to computer, from where you can have a display, you can have a mass storage, or you can get the hard copy, or you can use another image processing software to get more insights into that problem domain. So sensors, to acquire digital images, two elements are required. First is a physical device that is sensitive to energy radiated by the object we wish to image. The second, called a digitizer, is a device for converting the output of the physical sensing device into digital form. Example, video camera. The sensors produce electrical output proportional to light intensity. Specialized image processing hardware. Specialized image processing hardware consists of the digitizer just mentioned plus hardware that performs other primitive operations such as arithmetic logic unit, which performs the addition and other logical operations. Computer is an image processing system and is a general purpose computer and can range from a PC to supercomputer. Image processing software. Software for this is a specialized software that will process the data from the image processing hardware. Now, whereas this particular software is used to perform analysis at a very deep level. For example, we can use MATLAB. Image displays. These are nothing but monitors. Hard copy, devices for a printed copy or any other devices. And mass storage, that is the data that is being arrived from this particular digital system, either can be stored for a short-term purpose or on online storage or for archival storage. Now in this slide, we will see a basic element called sensing element of the digital image called sensor. So this is the basic element. Now this consists of, see here, from here energy falls and there is a filter for that one, and then next sensing material is housed in this particular housing, and this sensing material proportional to this energy incident on this particular region, it will gives you the proportional electrical waveform out. Now this particular basic sensing element either arranged in an array, in a one-dimensional array, or they are arranged in two dimensions, So this is how. Here the first one is source of light. This falls on the object of interest, and there will be a reflection, and this is called pinhole imaging system. And the internal, that pinhole will consist of this particular matrix array of pixels. Now the sensed object will look like this, which is a digital version of this physical object. And now comes to the image model. So image is two-dimensional function f of x comma y. The limits are from 0 to capital L, and f of xy is the product of illumination and reflectance. So the illumination range is 0 to infinity. That is, a light source may vary from 0 to infinity. Reflectance will vary from 0 to 1. And the gray level at a particular location is L. And this L is also a discrete and lies between minimum to maximum. And we will take the minimum as 0, maximum as capital L. Sampling and quantization. This we will discuss in our next class.